Hi guys, today we are going to study about the steam turbines and its classifications. Well, what is a steam turbine? A steam turbine is a machine that converts the heat energy of the steam into mechanical energy. The heat stored in the steam is converted into work in the form of rotation of a shaft. This energy can then be used to drive other machines. Turbines are mainly used in thermal power plants to produce electricity. Also, they are used to drive the propellers of the ship and machines such as the centrifugal pump. Well, the nozzle is one of the main components of the turbine. Let us see how this nozzle works. Well, a nozzle is a passage of varying cross section. The nozzle which is used here is a convergent divergent nozzle. This is so called because the cross-sectional area diminishes from the entry of the nozzle and then goes on to expand at the exit. So now let's find out what happens in this nozzle. Steam generated in a boiler enters the nozzle with high pressure and low velocity. As the steam passes between the entry and the throat, there is a pressure drop and the steam will expand. This will lead to a loss of enthalpy. There is no any external work or there is no heat transfer in the nozzle. Hence, to obey the law of conservation of energy, the steam will undergo an increase in velocity and hence exit the nozzle with a high velocity and low pressure. This steam is then used to run the turbine. Now, let us move on to the classifications of the steam turbine. Well, they are broadly classified into two types, the impulse turbine and the reaction turbine. Well, let us study impulse turbine with the example of a D-level turbine. This turbine was invented by a Swedish engineer named Gustav D. Laval and hence its name. This turbine consists of several curved blades fixed on the circumference of a wheel called as the rotor. This rotor is then connected to a shaft. The high pressure, low velocity steam generated from the boiler is made to flow through the convergent divergent nozzle. As we have studied earlier, due to the expansion of steam, the steam will then exit the nozzle with a high velocity and low pressure. This high velocity jet is then directed towards the moving blades of the turbine. The steam flows over these blades. During this, the steam will face a change in its velocity and direction, thereby resulting in a change of momentum. This change of momentum will generate an impulse force that will act in the direction normal, that is perpendicular to the blades, hence pushing the blades in that direction. A number of blades are fixed on the wheel and hence will cause the wheel to rotate at high speeds. This in turn will also rotate the shaft fixed to it. Hence, the kinetic energy of steam is converted into mechanical work. This work can then be utilized to drive the generators and to produce electricity. Next, let us study the working of a reaction turbine with the example of the Parsons turbine. Well, this turbine was invented by Sir Charles Parsons. This turbine runs by the reactive forces set up by the steam rather than the impulsive forces. This turbine consists of alternate rows of fixed and moving blades. The fixed blades are fixed to a stationary casing, while the moving blades are mounted to the periphery of a rotating wheel called as a rotor. This rotor is connected to a shaft. Unlike the impulse turbines, reaction turbines do not contain any nozzle. Instead, the blades are designed so that the spaces between the plates have a cross-section that resembles to the shape of a nozzle. In operation, the high-pressure, low-velocity steam from the boiler passes over the first row of the fixed blades. The space between these blades acts as a nozzle, due to which the steam expands and hence exits with a high velocity and low pressure. The fixed blades then guide the steam to the set of moving blades. As this steam moves over the moving blades, it will undergo a change in velocity and direction and hence a change in momentum. This will lead to an impulsive force which will push the blades and hence cause the rotor to rotate. Also, as the steam passes through the set of moving blades, it suffers a further drop in pressure as the moving blades also act as a nozzle. Hence, when the steam moves out from these blades, a reactive force is set up in the blades. Thus, the net force acting on the blades is the sum of the impulsive force and the reactive force. For this reason, this turbine is also called as an impulse reaction turbine. The similar process continues in the next row of the fixed and moving blades and so on. This will lead to the rotation of the shaft in high speeds, which can then be used to generate electricity. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live Magus videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.